Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Today, I want to have a look at the logical reasoning of science denial. And to use as an example, we're going to look at a recent video from Sleeping Warrior on Nathan Oakley's channel entitled Gravity. So, let's cue up the music and learn about sleepy gravity. Now, we saw in the interview between Jose J.G. Gonzalez and Nathan Oakley, generally they like to tag team, and this video is no exception. We're going to start off with Nathan Oakley laying the groundwork and poisoning the well, and then turning it over to Sleeping Warrior. Let's have a listen to Nathan Oakley.
And when Anthony's detailing them in the next 15 to 20 minutes, I want you to appreciate that he's working within their paradigm. So he's criticizing what they think the claim is versus what the claim actually is, notwithstanding that gravity, A, isn't a force, B, hasn't got a phenomenon of mass attracting mass, and C, we don't live in pseudo-force space. So all those things are notwithstanding. So when Anthony discusses it, it doesn't mean he's conceding that those things are true. He's just laying out the paradigm. So I don't want to hear any crap from people in the comment section telling me, so Anthony accepts that blah, 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 insert his version of what is being claimed versus the version that's being argued. Okay, you're on?
Are we up?
Yeah. Ready when you are.
Okay, so right off the bat, Nathan Oakley is setting up a straw man argument. He's saying that he's going to give us our argument, and then he's going to have Sleeping Warrior argue against it. But he's just doing that for academic purposes. He doesn't believe anything that he's talking about, and he's denying it all in advance. So, with that foundation, let's listen to Sleeping Warrior's presentation.
Newton's first law of motion states that an object in motion or an object at rest will remain in motion or at rest unless acted upon by a force. Fight the Flat Earth took massive issue with the fact that she didn't say an unbalanced force because he thinks that that's important.
Of course it's important. What would happen if you apply an equal and opposite force to this eraser? It won't move. If the forces are in balance, their net effect is zero. That's called vector addition. If you apply more force on one side than the other, then the eraser moves because the forces are unbalanced. That's the principle of the summation of vectors. So of course it has to be an unbalanced force. If it was a balanced force, the object wouldn't move. Can't you see that, Anthony?
It isn't important, and what I'm about to show is not only is he wrong, but even if he was right, it doesn't change the position. They still need to answer the question. So what I'm going to do now, flick over to the next page. I've not used PowerPoint for a long time. So this is a screenshot where after asking the question, F equals ma, where do you get the A from? He's working out, he's trying to use a load of mathematics to get to the A, the answer, and this is what he gives us the answer. And then he insists that this is satisfying the requirements for acceleration. And she's trying to get him to go back to the application of Newton's first law, which we're going to look at now. So this is taken from this particular book. It's in obviously Newton's laws of motion was written in Latin, and none of us speak Latin.
Qual este?
And you've got to allow for a little bit of wiggle room because there might be some element of being lost in translation. And what we're going to do is we're going to look at Newton's first and second laws of motion. And throughout what I'm going to say now, you've got to remember that the point I'm making is that they substitute the calculation of F equals ma in lieu of Newton's first law of motion.
We're substituting calculation in lieu of Newton's first law of motion. This should be good.
That's what they're doing. They're substituting mathematics in lieu of his first law of motion, okay? So he said, Fight the Flat Earth said, he focused massively on the unbalanced force bit, and he insists that Newton said it. But this is actually from Newton's book, Newton's Principia, however you want to pronounce it. Every body preserves in its state of rest or of uniform motion in a right line unless it is compelled to change that state by forces impressed thereon.
Okay, well, first of all, it's called the Principia. Second of all, That statement's pretty clear to me. He's very clearly indicating that you can have one or more forces acting upon a body and changing either its state of rest or its state of uniform motion. It makes absolutely no sense to try and argue that if you had several balanced forces acting upon an object with a net action of 0, you would change either its motion or the fact that it's at rest. That doesn't make any sense whatsoever. So let's see how he'll try and play with this definition to put some lipstick on this pig.
Now, it doesn't say unbalanced forces. And this is the final edition, right? So this is the most recent version of. He did a couple of revisions of it, but this is the most recent version of. It doesn't say unbalanced forces. So Fight the Flat Earth, when he dwells on the unbalanced forces claim from Newton, that is actually wrong. That doesn't come into it. That was substituted later. Newton didn't say it. So Fight the Flat Earth is incorrect to dwell on the unbalanced forces bit. It was substituted later on. But basically what this says in normal everyday language is an object in motion will remain in motion unless acted upon by a force. Okay, that's the first rule.
Well, let's unpack that just a little bit. So he wants to change it from forces to force. Okay, well, I can live with that. If you have one force acting on an object, it is by definition an unbalanced force because nothing is opposing it. If you have multiple forces acting upon an object, the object will respond to the net sum of all of those forces. If they are balanced, that net sum will be 0. If they are unbalanced, it will not be 0. If the force acting upon the object is not 0, it will have an effect. If it is 0, it will not have an effect. Is that a difficult principle for you to understand, Anthony?
So to get an object to accelerate, you have to give a force. You have to apply a force, an interaction, a push or a pull, a repulsion, a propulsion. Whatever word you want to do, there's got to be a doing word. It's got to have a verb to describe the interaction between the object that's not moving and the thing that's making it move. There's got to be something there, otherwise it won't accelerate. Okay, that's the first one. Now, what that also means is if you haven't got a force, it isn't going to accelerate. So an object at rest will remain at rest unless acted upon by a force, right? So it's not going to accelerate without a force, right?
Well, here's a big problem that you run into. If you accept force equals mass times acceleration, and there is no force, there will be no acceleration. That's correct. However, if there is an acceleration, there by definition must be a force. Now, to take your argument, if P, then Q. If Q, then P. If force, then acceleration. If acceleration, then force. So, for example, if you look at the pressure gradient in the atmosphere, by definition, there would be no pressure gradient absent an external force acting upon the mass of the atmosphere. There is a pressure gradient in our atmosphere, and by definition, that requires an external force to be acting upon it. Simply because you don't consider gravity a force based on your misunderstanding of the interaction between Newton and Einstein. You can't define a force out of existence by changing the terms. It just simply doesn't work that way, Anthony.
And in the second law of motion, which is what they always apply, F equals ma, it doesn't actually say F equals ma anywhere in Newton's second law. It says the alteration of motion is ever proportional to the motive force impressed, and it is made in the direction of the right line in which that force is impressed. And then it goes on to make some more. But the point is, it doesn't say F equals ma. That's simply a calculation. Now, these laws of motion essentially were superseded, or they were refined by quantum mechanics, which I'm not going to go into, but I want people to be aware that they were not right and they needed to be changed by quantum mechanics.
Well, there are three basic ways to look at gravity. You have Newtonian gravity, you have Einsteinian gravity, and you have quantum mechanics. Quantum mechanics is not fully defined yet. So our best understanding of gravity right now is Einsteinian gravity. Einsteinian gravity includes all of Newtonian gravity and expands it a little bit. One of the things that always amazes me about these science denial pundits that we're listening to right now is if you say that Newtonian gravity doesn't work anymore because it's been superseded by Einstein. How did Newtonian gravity work before Einstein came along? It worked very well. We designed bridges, we fired cannon shots, we did all sorts of things. Now, once Einsteinian gravity came around, we realized that there were certain times that we had to use it. For example, with GPS satellites. You need relativistic corrections for that. For the precession of Mercury, it was off by something like 44 microseconds per century. That's the error with Newtonian physics. Einstein corrected that error. So we're talking a very fine line between the two.
Let's flip back to that first one for a second, because I just want to point this bit out. Projectiles
Persevere, Tony. Persevere.
Basically continue in their motions so far as they are not retarded by the resistance of the air or impelled downwards by the force of gravity. Key word that, downwards by the force of gravity. Well, we all know that gravity is not a force because Einstein changed it in 1915 when he redefined gravity. He invented a whole new geometry. He limited the speed of light to a constant and basically radicalized gravitation from the force that Newton's describing here into an effect.
Do you remember our talk about the coffee cup, Tony? Two wings, same bird. It's very convenient in most cases to talk about gravity as a force, and the results are perfectly accurate for most calculations. They're called weak field calculations. So unless you're dealing with a supermassive black hole or speeds close to the speed of light, you can use Newtonian physics without fear of error. That's how we put satellites into orbit. That's how we went to the moon.
This is a really important distinction to observe, because if gravity is not a force, there can be no effect, because you need a force to cause the acceleration of mass.
So by your same logic, if we have acceleration of mass, by definition, we have a force. You're learning, Tony. Well done.
This is what Rachel was asking. Where do you get that acceleration from in F equals ma? Well, there is no acceleration of mass if you haven't got a force to do it. You need a force to accelerate mass. But what they're doing is substituting a force, and they're calculating the force as though the force exists. Well, the calculating isn't going to give you an accelerating mass. You need a force to do that, not a calculation, not a load of gibberish. Doesn't matter how eloquent your equations are, be them Einstein's field equations or fight the flat earth scribbling on a whiteboard. Doesn't matter how good your maths are, that doesn't accelerate mass. You need a force. So what these people are doing, and Rachel had them totally cornered, right? She had blue marble science on, and he was explaining to her how he did the Cavendish repeat.
That would be the Cavendish experiment, Anthony. And he built a reproduction of the Cavendish apparatus in his garage and donated it to the University of Tennessee School of Engineering. It's currently being used by engineering students. And he was actually able to determine the gravitational constant, big G, to within 1%. Strong work, blue marble science. Strong work.
And how he was, and she basically said to him, "What's making the balls accelerate?" And he's saying, "Well, it's obviously something that looks and acts like a force." And she said, "Well, what force is it?" And he can't answer that question. So these people will do everything to stop them from answering that question because their answer is gravity. But as we know, gravity is not a force. It was replaced by Einstein in 1915 as an effect. Now, let's just push Einstein a couple of steps further. Einstein was verified according to science in 1919 with the observation of Eddington, where he observed the stars behind the sun. And in doing so, he validated, according to science, he validated that Einstein was in fact correct.
And indeed he was. And it's been verified many times since. You know, simply because you cherry-picked a definition of gravity as not being a force does not mean that it doesn't act just like a force. That is the effect that gravity has. What causes gravity is immaterial. The fact that you have an acceleration means that there is something that looks and acts like a force acting on that mass. Period. It doesn't matter how you define what a force is. We'll use Newton's definition. And Newton's definition is described in the equation force equals mass times acceleration. And that works very well.
Because the observation of the stars behind the sun would not be possible unless space-time was bending, okay? So at 1919, that was verified to be Einsteinian, to be correct. That's the claim. Fast forward 100 or so years, and you've got LIGO. So mid-1990s, they started to build and got towards completing the LIGO observational thing, the gravitational wave observatory. And that was at a cost of $1.1 billion.
And this camera that I'm filming this with today cost 1.5 times 10 to the 4 pennies. That's a big number too. But I needed to get a decent camera, and it was worth it to me. Thank you, Patreons.
If LIGO detects gravitational waves, and it's supporting Einstein because it's gravitational waves, Newton didn't have gravitational waves. He did have changes in direction of gravity when accelerations occur, but he didn't have gravitational waves, and that's what LIGO is specifically detecting. It proves that Einstein is correct and not Newton. So it goes beyond the Eddington observation, and it is claimed that by having gravitational waves, Einstein is correct and Newton is not. And that is the current position in science today. Not that I agree with it, I don't, but that's what the current position is in science today.
Anthony, I think your biggest problem is this concept that somehow somebody has to be right and somebody has to be wrong. Newton was correct. Einstein simply more correct. That doesn't mean that Newtonian physics all of a sudden doesn't work anymore. It certainly does. It doesn't mean that because Einstein is better than Newton, we have to calculate every bridge and bullet with Einsteinian tensor calculus. We don't. Now, more importantly, you can't make the argument that since Einstein replaced Newton, and Newton is just math, therefore gravity no longer exists. You can't define something like gravity out of existence. As much as you want to do that, you just can't.
Because gravity is not a force, it doesn't accelerate and cannot accelerate mass. That's the current position in physics today, science today. But they want to apply Newtonian gravitation at all times because they want to insist that mass attracts mass, and Newton's universal gravitational theory insists that mass attracts mass. They want to apply that always, and it's not the current position in science anymore.
Now, here's an interesting situation that we find ourselves in. Anthony is arguing that because it's mathematics, we can't calculate a force into existence, but he wants to define one out of existence. Einstein described gravity a little bit better, and it not only covers all of what Newton said, it covers a little bit more. And he defined it as a warping of space-time. Now, mass affects the warping of space-time. So in reality, Einstein is also talking about mass attracting mass indirectly, because the two masses affect their local spacetime. The same principle that you see with Newtonian physics. Just as the Cavendish experiment clearly shows mass attracting mass, that's perfectly explained with Einsteinian gravity as well, because the two masses in the Cavendish experiment are simply warping their local space-time, and the result is that they move towards each other. The effect is exactly the same. Something that the flat earthers seem to have a great deal of trouble with is the fact that there's only one gravity. It's called gravity. Newton and Einstein both had ways of describing that gravity, which were slightly different and took different approaches, but they were describing the same thing. It doesn't matter if you describe this coffee cup, either by the color of the cup or the volume of the cup. You're still describing the same cup. Einstein himself said that he worked upon the shoulders of giants, especially Newton, and nothing that he could say would supersede the great work of Newton, is the way the letter quoted him. His work adds to Newton. It doesn't replace it. And quite frankly, in physics, if you're looking at normal size objects, say up to the size of a planet, and you're talking about the orbit of the planet or how to put a satellite into orbit or how to fire a cannonball and hit a particular target, you're dealing strictly with Newtonian physics. If you mention the word force when describing the relationship between motion and mass and objects in this universe, you are by definition using Newtonian gravity, because Newtonian gravity is a force. If you are talking about the disturbance of space-time, you can discuss Einstein. But if you mention the word force, you lock yourself into discussing Newtonian physics.
hear me